now now we are going to the in previous two chapters we have seen that what is the unsupervised learning and what are the types of the supervised unsupervised learning, and uh, after that we have we went through the clustering, and we have seen that there are the various algorithms for the clustering, and in that basically there many times we are going to deal with the k-mean clustering and DB scan clustering and hierarchical clustering. So in previous section we have seen that what is the k-mean clustering with the numerical example, that how to apply the k-mean clustering to the given data sets. Now we are going to see that how we will work with the hierarchical clustering. So first of all we should recall the that what is the hierarchical clustering. Hierarchical clustering is nothing but it is going to the going to build a hierarchical structure, tree like structure structure structures, and that is going to have a clusters. uh, this this can be basically divided into the two different types, like agglomerative and divisive. In agglomerative we are going to merge the data. Excuse me. In agglomerative we are going to merge the small data to to the we are in the agglomerative clustering we are going to merge the small data sets like this data set, this data set, small data set to the one larger data set, making a tree like structure. Okay, agglomerative. So this is a bottom to up approach, and second one is the divisive. Second is a divisive. In this we are going to split the data means we if we have the if we have the like data set like this data set, so we will going to divide the data sets into the smaller chunks. So this is a top down approach. So now this we can see this diagram is called as the dendrograph of the hierarchical clustering. Okay, so now we have this numerical value 1 5 8 10 19 and 20. We are going to the apply the agglomerative clustering in this. Okay, so what the data sets we have? What the data sets we have? One 5 8 10 8 10 19 and 20. So for this data set, as we know, To find out the similarity between the two data points, we are going to deal with some mathematical uh, formulas like Euclidean or approximate matrix. Here we are going to deal with the approximate matrix. So by clearly see, we can see that this is the our numerical value 5, 8, 10, 19, and 20. So here we can just clearly see that 19 and 20 are very close, because the distance between 19 and 20 is very minimal. After that, see the distance between 10. So now this will be the work as a single data sets. So previously we have 2 to 4 to 6 data sets. Now we are having 5 data sets. This 90 and 20 will work as a single data set. Now we can see that here distance is 4, here is distance is 3, here distance is 2, and here distance is 9. So closest distance is between 8 and 10, right? After this we can see, now we have how many data sets? 1, 2, 3, because 8 and 10 will be work as 1, 3, and this one 4 data sets. Now we can see who are the closures. So we can see that 5 is very closer or very near to the 8. Okay, now after this we can see 1 is very close to the 5. Okay, now we can see this is our final dendrograph of the agglomeratic hierarchical clustering. Fine. So as we have seen, sorry, I have forgot to update the data labels. So this data label will be 8 comma 10. This data label will be 5 comma 8 comma 10, and this will be 1 comma 5 comma 8 comma 10, right? And this will be the 1 comma 5 comma 8 comma 10 comma 19 comma 20. Okay, now as we know that agglomerative is the bottom to upper approach and divisive is the top to bottom approach. In for that we will see the same example, that is one, and that is one. The data set, what was the data set? What are the data sets? 1 comma 5 comma 8, comma 10, comma 19, comma 20. If this is a data set, we can see this is a data set, and we are going to find out the similarities between the individual data sets and going to divide these whole cluster into the small chunk, or we can say small clusters. So clearly we can see from this that the nearest points will be having the more similarities, right? So here we can see that 19 and 20 are more similar than this. So we will divide this in 19 comma 20, and further this can be divided in as 19 comma 20, and here we have 1 comma 5 comma 8 comma 10. So now we can see the very closest are these value, right? This one is the very far away from this value, so we can have 1 as a separate and 5 comma 8 comma 10 as a whole, and again we are going to divide this as 5 8 comma 10, and this can be divided as 8 comma 8 and 10. So we can see clearly here we have followed the top down approach for doing this divisive hierarchical clustering. Okay, thank you.